According to many resources, there's a downside to subnetting. And those resources indicate that the downside to subnetting is that fewer hosts can exist in a subnet than if we had that original subnet. Well, that makes sense. Because if I have a really, really large network, like a Class B network, using its default subnet mask, I can have a total of 65,534 devices in that subnet. But if we break up that network, meaning we subnet it into 256 subnets by borrowing 8 bits. So if I borrow 8 bits, I now have a /24 network. Well, I created 256 networks, and each of those networks can only have 254 hosts in them. So that's what they're saying is the drawback to subnetting, is that you have less devices in each of your networks. So notice how we've deployed 172.16.1.0 over here. We've deployed 3.0 over here. We've deployed 4.0 over here. And then we have 2.0 over here. Each of these networks can only support now 254 hosts instead of having that one large network that supports 65,534 hosts. Now, is this a big deal? No, not at all. Is this a downside? Not to me. And it shouldn't be to you either. This first bullet point, the downside of subnetting, to me, that's more of a primer to get you pumped up. Am I getting you pumped up? Why is this not a downside in reality? Because can I even have 65,534 hosts inside a single network, inside a local area network, off of a one router interface? No. Well, I can. But would it function properly? Probably not. Why? Just think about broadcast traffic as a simple example. If all 65,534 hosts broadcasted at the same time, that means every device is going to have to process every single one of those broadcasts. It'd be a nightmare to troubleshoot that network as well. It'd be a disaster. So you know what? I want smaller networks. So what are practical sizes for our networks? Well, limit your Ethernet LANs and your VLANs, where you're going to have your end users and your phones, to just 254 users. So really, I don't need a subnet any larger than 254, do I? No, not at all. Not at all. It's not needed. So even if I'm a /8 network starting out, I can support 16 million users. What? That's not even practical. That wouldn't even work. Now, I'm not saying in all cases. What if you had a whole bunch of bridge sensors? Whole bunch of bridge sensors. Their job is to gather statistics about the movement of the bridge, meaning vibrations from cars driving over it, earthquakes, shift in position. Has the bridge actually moved 1 millimeter since we built it? All right. Yeah, having all those devices with an IP address being able to communicate back to a central server, we could have millions of those inside a subnet. But I'm talking here about our enterprise network, where we have our phones, our PCs, our printers, our wireless access points, our servers, our point-to-point WAN links, our point-to-point Ethernet connections, DMZs. What's practical in those cases? Well, definitely not a /8, definitely not a 9, a 10, an 11, a 12. No, none of these are practical. So where does practicality start? Right down here, /24. /24. 254. So Ethernet LANs and VLANs, 254, and every other network's going to typically be smaller than that. So wireless LANs, 30 to 62. Why? Because they're half duplex. Everybody's competing for the wireless radio airwaves and the wireless LANs. As a result, the more devices you have, the slower it's going to become that wireless LAN. So 30 to 62 devices per wireless LAN. Point-to-point WANs. Well, we only need 2 addresses there. That's it. Just 2 IP addresses. Point-to-point Ethernet connections between routers. Again, only 2 IP addresses required. Multi-point wide area networks, meaning a hub and spoke style of topology where we have headquarters and we have branch offices connected to headquarters through the same WAN. 6 to 30 as an example. And DMZs, well, it really depends on the DMZ, depending on the number of servers you have per customer, per client, for yourself. So in practical terms here, do we ever go above 254? No. So in the real world, typically what you're going to find some organization using the 10 network, class A. So 10.0.0.0/8. And then what do? They subnet it. They subnet it down to what? /24. So they borrow 16 bits, 2 to the power of 16, 65,536 subnets created. And every single one of those subnets now support 254 end stations. Much more practical use of our addressing now. As you start to go above 254, 510, 1022, 2046, you're not going to experience major difficulties, but it's definitely not recommended practice. You definitely want to do your best to keep 254 and lower for your different Ethernet LANs. So again, what describes an Ethernet LAN? Well, it's all the devices that are part of the same network off of a single router interface. So what does that mean? It means that all 254 of those users are going to be using that router interface as their default gateway. So again, it makes practical sense there as well, because that's 254 devices that would all be using that router as its exit point. Single points of failures, bottlenecks. So even if we have multiple routers set up, doesn't matter for the default gateway. Doesn't matter. Again, we still have 254 devices down in that local area network, all wanting to get out to different parts of the network. The DMZs, the data centers, the internet, the WANs, whatever it happens to be. So practicality-wise here, 254 and lower is the way to go. So it brings us back. Is that a downside? Of course not. Of course not. Having fewer hosts in our subnets makes it more practical from a real world standpoint. That's really what it does for us. So we definitely want a subnet. We want to take large networks, break them up, divide them up into smaller, more manageable networks. We're going to benefit from having those smaller, more manageable networks. And then on top of that, we're definitely going to have improved performance by having fewer hosts inside each of those networks.